First of all, let's load a schema. Go to the File menu, press Open Schema, and you'll be presented with a schema import wizard. In the first step, select whether you want to import a schema as a source schema or a target schema, and then choose whether you want to read it from a file or from a web feature service. We're going to load a schema from a file. Press the Browse button, pick the schema that you want to load, press Open, and then Finish. You'll be presented with the loaded schema in a hierarchical tree form in the Schema Explorer. You can just press these plus buttons to explore the schema. You see that there are abstract feature types and concrete feature types. Then below that you have all the attributes that belong to this feature type, such as simple integer attributes, string attributes, or geometric attributes like this one. You can also filter on these types of attributes. So for example, if you only want to see the geometric attributes, you can press hide string and hide numeric attributes. Another possibility to filter on the elements being displayed in the Schema Explorer is using the entry form above, which will filter any element in the tree below. It is also possible to load a schema from a web feature service. To do so, again, go to File, Open Schema, but this time, instead of choosing Read Schema from File, pick Read Schema from WFS Describe Feature Type and press the Change button. First of all, enter the Get Capabilities URL of the WFS from which you want to read the feature types. In this case, we have an example entered here. Then press the Validate Settings button, which will lead to the presentation of all the feature types that are available on this server. If your web feature service offers more than one namespace, you will also need to select a namespace. Let's pick the Italy one. Then click Use this WFS and click Finish. After loading a source schema, you can also load some instance data expressed in that schema. To do so, go to File, Open Instance Data, and then pick a file via clicking on the Browse button. Press Finish and your instance data will be imported. Pick either the appropriate CRS code or the well-known text. When you've loaded the instance data, you can use the map viewer to navigate through the instance data. This can be done simply with your mouse. With your mouse wheel, you can zoom in, and by pressing the left mouse button, you can pan to the left, right, top, and bottom. This map view can also be configured in the way it displays the data that you have loaded. To configure the display, first of all, press this button, which allows you to define styles for each of the feature types that you've loaded. In this case, we have just one source SLD for watercourses. We'll click on it and we'll present it with a configuration of how it's currently supposed to render the features. We can see that in this case it's a line symbolizer, since the features that we have loaded represent line string geometries. But a configuration can also be done for points and polygons. In this dialog, you can also define filters. Filters allow you to specify the look that a feature is going to be rendered with, depending on one of its attribute values. You can enable a filter by clicking this checkbox, and then by picking the attribute on which you want to filter, an appropriate operator, and a value. And you can say, for example, increase the value. Let's pick a color that can be seen in a better way, like yellow, and let's apply this. And now you can see, compared to before, only a small set of the objects is actually going to be rendered. After exploring your source schema and the data that you want to transform, you would like to continue with the mapping. In this case, you also need to load a target schema. Again, go to File, press Open Schema, and choose Import as Target Schema. Click Browse, and pick the target schema that you want to transform to. Your schema is now loaded. Let's create a simple mapping now. First of all, select the type that you want to map from the source schema. Then select the type that you want to map from the target schema. As you can see, the button in the middle between the two areas has now become activated. You can now select a mapping function. In this case, there's just one function that's currently available, the rename wizard. Pick that one. The rename function allows you to express that features of one type should be renamed to represent features of another type. In addition, you can also decide whether a split of instances is to be done. In this case, we don't want to do any splitting and just press Finish. After the mapping has been created, the types that you have mapped appear with a green background. Often, a mapping is not unconditionally valid, and you have to apply a filter to specify when it should be applied and when not. This can also be done in this software. Again, pick the two types that you have connected via a rename mapping. Now, press the arrow button in the middle again, and you'll be presented with two additional options, one being a CQL-based filter string form and the other one using a form. We'll pick that one. In this dialog, you can now choose on which condition you would like to filter. We're going to pick an attribute, and we're going to state that this attribute's value should be equal to a value of 1. As you can see now in the mapping view down here, we have now the details on this mapping, including the filter, which is defined here, where it states that level should be equal to 1. Since we have loaded instance data before we started with the mapping process, we can also interactively evaluate the results of the mappings that we define. In this case, go to the map viewer, and instead of picking reference data only, pick any of the other modes. Let's start with the split vertically one. In this case, what you can see is on the left-hand side the original data, and on the right-hand side the transformed data. It's quite obvious that the mapping is in effect, since only a small subset of the features on the left side actually made it into the transformed data set. And what is also obvious is that there seems to be some issue with the geometric type. So, for this case, we can define an additional geometric transformation to handle this. If your target schema requires a different geometric attribute type than your source schema, there are also specific transformations available for handling that. Just as an example, let's transform the geometry from this type, which is a multi-line string property type, and to the geometry from the target type, which is a geometric primitive property type, using a specific mapping function called network expansion line to surface. This function, as you can see, creates a buffer around each of the objects and thereby creates a polygon from a line string. Double-clicking on the map viewer will allow you to get a larger view so that you can get a better impression of how the transformation has affected the objects that you're working with. Another common mapping problem that we have to deal with is the mapping of classification systems. In this example, we have a classification system which is hidden behind the attribute called level on this side and behind the fictitious Boolean value on this side. To map those two, select the two and then choose classification mapping. What you can do now is you can enter a value for watercourse fixtures, which is the target value. Let's just, since it's a Boolean value, we can just add true. And then you can add values, for example, 1, 2, 3, and 4. You can also add additional values. For a Boolean value, only false as a second meaning is helpful. So let's add 5, 6, and 7 here, which now means that all values assigned to true, 1, 2, 3, and 4 in the source schema, will become true in the target, and all values assigned to false, 5, 6, 7, will become false in the target. Let's finish this. The Humboldt Alignment Editor also supports some of the specific data structures that the Inspire data models are using. One of these is the identifier property type that is used to uniquely identify each and every object that is available throughout the Inspire SDI. To create such an identifier from a rather simple identifier like this integer value, again, press the mapping button and choose the Create Inspire mapping function. In this dialog, you are presented with several options, including a country code, your provider short name, and the product name which you're working on, and finally also the type name, which is pre-filled in. Press Finish, and you'll have a more complex URN for your object being created from the simple input. Another function that is specific to supporting Inspire is the nilReason function. For every object in a target schema, you need to provide information when a certain field is not populated with an actual value, why that is the case. In the alignment editor, you can select such a case. You'd select just the target attribute for which you want to define it and pick the nilReason augmentation function. Here you can either choose whether it's unknown, that means that basically there will be a value for some of the instances but not for all, or whether there is no value at all in the source data set, so the entire condition will be unpopulated. After defining your mapping, it's time to save your result. Go to File and pick Save Alignment Project As. You can now browse for a file location, enter some project metadata like your project name and the author, and press Finish.